All right, guys, now we are on to page 3. Now, with page 3, you'll notice we have what's called distributive practice. That means review. That means stuff that we've done in the past that we're going to continue to revisit a number of times just to make sure that we're constantly keeping it fresh. It's kind of honestly, it's a way to get ready for the final exam in January or in June. So you're getting a chance to see some of the same stuff again so we don't completely lose it and have to try to relearn it all over again. So this first one is density application. How do we apply the concept of density? Using the water displacement method, please find the density of the section of rebar, should be of rebar, based on the data below. Now, we're not given the formula for density, but hopefully it's something that you do remember, whereas density is mass divided by volume. And so when we have the mass of the object, we can divide that by the volume. Now, we are given the mass here. Okay, they tell us what the mass is. The mass is 69.658 grams. Now, what we don't know is the volume. We do, however, know the starting volume of the water, and you can see that right about here. But they tell us that it's 13.5 milliliters. Then you drop the rebar in, and then the water goes up to about here, where that means it's 22.4 milliliters. So the question is, what is the volume of the rebar? That we don't know. Well, to find that, we'll need to take 22.4, that's your final volume, minus 13.5, that's your initial volume, that's the starting volume. So 22.4 minus 13.5, and that gives us 8.9 milliliters. So our volume then is 8.9 milliliters. So now we can do the math to find the density. So we'll take 69.658, divide that by 8.9, and that's going to give us 7.8267. I'm going to say 7.83. Now, watch the units carefully. It's grams per milliliter. We want to make sure that we include the units in there. So that's kind of water displacement for that first example. The second one was unfortunately missing a little bit of information, and that's the math. We're going to set it up basically the same way. We see that we have the initial volume of 80 milliliters. The final volume is up here at 100 milliliters, which if we go 100 minus 80, we see that the steel ball bearing in here has a volume of 20 milliliters. Now, if we're given that the mass is 170 grams, mass divided by volume, we'll take 170 grams, divide that by 20 milliliters. 170, divide that by 20, will give us 8.5. 8.5 grams per milliliter. Now, the question says, what is the ball made of? Okay, determine what the ball in the cylinder is made of. So if we see that it's 8.5 grams per milliliter, I look through here and I see, the ball is made of brass. That's what we're looking for. Okay, we want to answer the question, what is the ball made of?